To describe the x and y values of points of relations in the language of math, there's a few things that we need to know. We need to know how to describe different types of numbers. We have natural numbers, which look like 1, 2, 3, and so on. Sometimes we call these counting numbers. And in math, we use this symbol to describe them. It's just an N in a funny looking font. Later, we added the number 0. We usually don't count with the number 0. And if you include the number 0 in this set of numbers, you have the whole set of numbers, and we use a W to describe that. So whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, up to infinity. And we know about the integers. So the integers include 0 and all these positive numbers, as well as the negative integers. And the integers are not described by the letter I, they're described by the letter Z. And they include all the whole numbers and therefore all the natural numbers. So we also know about, we know that fractions can represent numbers. We call fractions rational numbers. And they include numbers like a half, negative 3 over 2, 5 over 7, and so on. And we use a letter Q to describe that set of numbers. And that set of numbers includes integers and whole numbers and natural numbers, because integers, whole numbers, and natural numbers can be described as fractions. So there are numbers that can be written as a fraction, and they're called rational. And then there are irrational numbers. Described by Q prime. And those are numbers that can't be written as a fraction. So for example, pi, the ratio of the circumference of a circle to its diameter, the square root of 2, you can't write that as a fraction. There are other numbers that are irrational, but they cannot be written as a fraction. So we have rational, we have irrational numbers. If we put both of those together, we have real numbers. And there are no real numbers that are neither rational nor irrational. So I'm just going to color in this area to show that. Now, if we want to talk about values of x and y coordinates, it's very useful to be able to say the number is bigger than this, or it's less than or equal to this. So we have symbols in math that communicate that. So for example, we could say x is greater than 2. Okay, so x is a number that is bigger than 2. Sometimes people get confused with which direction to point this symbol. Easiest way to remember it is that the larger of the two sides, okay, is where the large number goes, and the smaller of the two sides is where the smaller number goes. Now, if you think of it that way, you'll be able to recognize that this expression and this expression are actually equivalent, okay? So if you say that x is bigger than 2, or that 2 is less than x, you're saying the same thing. So we say x is greater than 2, 2 is less than x. Sometimes we want to say a number is greater than or equal to. So it could be 3 or it could be more. We would write that. And of course, we could write the same expression like that. So the different types of numbers represent sets. We talked about the natural numbers or the counting numbers, and we said that they are 1, 2, 3, and so on. In math, that collection of numbers is called a set, and we use these curly braces to describe a set. Okay, so it's a bunch of numbers. There's an infinite number of them. That is a set of numbers. The whole numbers, similarly, we can write almost the same way. It's the same set, it just includes 0. The set of integers, we might write it like this. And we put some dots there to show that the numbers continue in both directions. That is the set of integers. Writing out the set of rational numbers in any kind of intelligible way, or the way we're doing here, is going to get a little bit complicated. So I'm going to stop at this point. But the point to remember is that these are sets. Each of these represent a set of numbers, and each set, as you can imagine, has an infinite number of numbers in it. So we have this idea of a set. So using this new set notation, which is just a way of describing sets in the language of math, we can write things like 7 is an element of this set. So we have a way of writing this sentence in math notation. We can also say, instead of using the curly braces, we can say that 7 is an element of the natural numbers. 7 is also an element of the whole numbers and integers and real numbers. I could keep going on here. But these are all sets. So let's say I want to describe the set of natural numbers that are over 100. Okay, so I've written it there in English. I want to use math notation. So what I can say is x values that are part of the natural numbers where x is greater than 100. So I'm describing a set here. I'm saying x is a natural number and it's over 100. I might also write this another way. And it's pretty descriptive and pretty straightforward what it means. But sometimes it's not as possible to write things this clearly, and so we need this slightly more complex notation to be very precise when we're talking about sets of numbers.